Today we're going to look at composite functions and how we can differentiate them a lot faster. So if we had 2x plus 3 cubed, right now our only option is to write it out into polynomial form, which would mean I'd have to take 2x plus 3 times 2x plus 3 times 2x plus 3. Whew. Okay, so I'm going to multiply the first two together and get 2x times 2x is 4x squared. I'd have a 6x and another 6x, which is 12x plus 9. Now multiply that by 2x plus 3, and we get f of x is 4x squared times 2x is 8x cubed. 4x squared times 3 is 12x squared. Now distribute the 12x. 12x times 2x is 24x squared. Then I'd have 36x. Now distribute the 9. Whew, it's long. Combine like terms. We have 8x cubed, and then 36x squared, and then that's 54 plus 27. Now we can use the power rule. So f prime would be 24x squared plus 72x plus 54. But you ask yourself, there's got to be an easier way. Ugh. Especially if that had been to the 7th power or something. Well, there is an easier way. So this was another one that Leibniz found or proved. It's about if you have a chain. So if we have a composite function, h of x equals f of g of x, Leibniz found that there was a shortcut. Love shortcuts. So I'm going to find the derivative of h to be, if I take the derivative of the outside, keeping g of x just like it was, and then multiply that by the derivative of the inside. Let's show that that works. So for this function, the inner function is the 2x plus 3, and the outer is something cubed. So I want to show you how this works. F prime of x is going to be, if I take the derivative of the outside, I can apply the power rule, which would be 3 times whatever squared. Well, the whatever is the 2x plus 3, not just an x. So I'm going to multiply by the derivative of the inside, which is 2. Well, I want to show that these two things are the same thing. So that's 6 times 2x plus 3 times 2x plus 3, which is 4x squared plus 12x plus 9. And if I distribute, I get 24x squared plus 72x plus 54. A lot faster. Really comes in handy for things like this. We have f as being sine squared theta. Remember what that really means. That's sine of theta squared. And we're asked to find the slope of the normal line. Ooh, make sure we remember normal. Okay. So first off, I need to find the derivative. So the outer function is something squared. So that's going to be 2 times whatever that was to the 1 power. I'll show that. Well, the inside was sine theta. So I multiply by the derivative of the inside, which is just going to be cosine theta. Now if I plug in my value for theta, I'm going to get the slope of the tangent. So that's 3 pi over 4. That's going to be square root of 2 over 2. Cosine of 3 pi over 4 is going to be negative square root of 2 over 2. And I end up getting, see, those will cancel. It's going to be a negative square root of 2 times square root of 2 is 2 divided by 2 is a negative 1. Now remember, this is the slope of the tangent. And we were asked to find the slope of the normal line. So the negative reciprocal is 1. So the hardest part about these is figuring out what's the outer function and what's the inner function. So recognizing what's the inner and what's the outer is really important. So the inner function is this one. So when I take the derivative, I start with the outside. 3 goes down. Whatever's on the inside squared. The inside is 3x squared plus 2. So I need to multiply by 6x. And I know we can simplify that, so we're just going to leave it there. Let's rewrite g of x into being 2x plus 5 to the 1/2 power. So now the inside is the 2x plus 5. Power rule is applied to the outside, so 1/2 times whatever's on the inside to the negative 1/2. And that's 2x plus 5 times 2. We might ought to practice with this one, simplifying. We've got a 2 and a 1/2. And just to remind you, negative moves it to the denominator. And so that's going to be the square root of 2x plus 5 in the denominator. Ooh, let's rewrite h of x as x plus 2 to the 2/3. So this is the inner function. The derivative is going to be power down, x plus 2, subtract 1, times the derivative of the inside. Well, that's just 2 over 3 cube root of x plus 2. F of x is going to be 5, and then this is going to be x squared plus 2x to the 1/3. Inner function. F prime is going to be 5 times 1/3 is 5/3. Subtract 1 from the exponent. This was the inner function. So times the derivative of that, which is 2x plus 2. I mean, if we want to practice making that prettier, those are both going to be in the numerator. And then I'm going to have 3, and that's going to be cube root of x squared plus 2x squared. What does this actually mean? So capital G of x really means that I have cosine 3x squared. So the inner layer is this, but there's an inner layer inside cosine. Oh boy, okay. The derivative, outer to the 1 times the derivative of cosine of 3x, which is going to be negative sine of 3x. But that has an inner function too. So times the derivative of the inside function, so times 3. That's going to be a negative. 2 times 3 is 6. Cosine 3x, sine 3x. Oops, let me just rewrite it first. H of x equals sine of 2x plus 1, and all of that is squared. So the outer function is squaring it. So now I'm going to have 2, then whatever was on the inside. I'll try to do a different color on this one. To the 1 power times the derivative of the inside, which is going to be cosine of 2x plus 1, times the derivative of the inside of that. Two times 2 is going to give me a 4, and then we're going to have sine of 2x plus 1 and cosine of 2x plus 1. The next few problems combine everything. So I want to see if you can try some of those, and then we'll go over those in class. Actually, I think I'm going to let you present in class.